starting the recording because I need to get right into this lesson, okay? We're reviewing law of sines and cosines. You either had trigonometry for a whole semester, or you had honors algebra 2 and probably honors geometry. Okay? Law of sines and cosines is taught in honors geometry. It's taught in honors algebra 2. It is also taught in trigonometry. So everybody should have seen this before at some point. The thing about law of sines and cosines is that they work to solve any triangle. It does not have to be a right triangle. You don't need SOHCAHTOA stuff, okay? They work to solve any triangle, which they call an oblique triangle, okay? You can apply law of sines if you know any two angles and one side. So they call it, you can use AAS or ASA from geometry, okay? If you have two angles and a side, then you can automatically find the third angle, right? And then you'll be able to set up a proportion. Now, when you set up a proportion of, oh, of course I don't have the cursor working. Here we go. Like sine A over A equals sine B over B, or sine C over C equals sine B over B. You don't need all three, okay? We don't do things with two equal signs. Just pick two that you need. All right, and it's also going to work when we have side-side angle, and that's going to be a special case. I'm going to have some situations when we have that. All right, this is what it looks like at the top of your sheet. Okay, you will, on the quiz, have to have this memorized. It's not on the pink sheet. And you will be asked on the quiz to state law of sines. So you could write down something like this, or if you prefer to do them upside down, it's the same thing, right? Any questions about that? And if you put C and C in here instead of A and A, it's all good. All right? So, what mode do we need to be in for these questions today? Degrees. Can you make sure your calculator is in degree mode? Oh dear, that's not what I wanted. Hannah's gone today and Ian's gone. Said it. All right, I need to change my calculator here to degrees. Then we're all good? Okay, so for this question, they want us to find B and C. And I didn't talk about this yet, but you remember this business that they will use capital letters for angles and lowercase straight across from them to represent sides, which I always love because big C and little c, they're very different looking. Not. Okay. So this is the picture we're talking about. What can we find first? What do we know across from each other right now? A and angle B we know, so we could find side B first. Does that seem all right? Is this coming back to some of you? The sine of 30 degrees is across from a side of 15 in the same way that the sine of 100 degrees is across from a side B. Cross multiply and divide. So I'm going to type 15 times the sine of, and it brings up a parenthesis. So what do I have to do? Close that parenthesis, or I don't get the right answer. Okay, I'm multiplying these two, and then I'm going to divide by the sine of 30 degrees, and that one, if you didn't close it, would still work. 15 sine of 100, close parenthesis, divided by sine of 30. Anybody getting 29.5? What did we just find again? A side. So that's a length, right? So I could label it units. It's not degrees, whatever. They didn't give us any units. All right, we still need to find side C, it said. How are we going to find side C? Sine of 30 over 15. I would definitely use that pairing because they gave those both to us. But then we need this angle. How are we going to find that angle? Oh, we're going to subtract from 180, and that's left 50 if I did that right. So we're going to do sine of 50 over C, and then we're going to type that very carefully, remembering again to close parentheses. What'd you get? 23? Everybody agreeing? Anybody have a question? All right. So when it says solve a triangle, not my favorite, it wants us to find everything. Okay? Solve a triangle means find all the missing lengths and sides. And it says to round them to the nearest degree or tenth of a length. All right, 150 and 20 makes angle B, what, 10 degrees? Did I do that right? All right, so now we need a couple sides. We need to find, what is this side over here called? The longer one over here, or the one across from B. This would be little b. And over here, this side is going to be called little c. Okay. Doesn't matter which one we do first. Sine of 150 is across from 200 here. In the same way, sine of 20 is across from C, or sine of 10 is across from B. Oops, sorry. Yeah, 136.8 for C. Did anybody else get that? And for B, 200 times the sine of 10, close parenthesis, divided by the sine of 150. Am I going too fast, and are you all good with typing in proportions without too much thinking? Okay, 69.5 for B, anybody? Is there anybody needing help with getting these answers to work out? All right, so that's law of sines. Can I skip number 2? Yes, because it's the same, right? You got to find you can't start until you find this angle, right? Because nothing else is known across from each other. This is called an angle side angle situation. But if we do 180 minus 63 and 38, this is 79 degrees. So then we could find side M and side P, same way as we did the last ones, right? Can I skip that one, guys? Anybody need to see another one? All right. The other situation that can happen with law of sines still is that you can be given two sides and an angle that's not in between. For example, this shows a side C that's 2 inches long, a side A that's 0.3 inches, and an angle A that's 30. This would be two sides and an angle not in between. Do you remember in geometry you tried to write this on your paper and your teacher said that doesn't work? Okay, remember that? Okay. This doesn't work. It doesn't make a triangle at all in this situation. In this situation, given two sides and an angle over here, it makes one single triangle. But it is possible that given two sides and an angle, it's possible that 1 inch piece went this way or this way. Do you see what I'm talking about here? It's possible to get two triangles. That's why this is called the ambiguous case, means more than one possible solution, okay? All right. So let me show you where this comes. Oh, there's rules in your book? These just give me the heebie-jeebies. It says if A is less than B and A is less than H, I don't even know. These are rules for when it's one solution, two solutions. I don't even know these rules. I just solve the problem and figure it out if it's going to work or not work, okay? Let me explain it trig-wise. Can you just look up here for 1 second? This is even down in the lower right corner of your notes, right? This little graph. Okay, on the front side, lower right corner, it shows this. I didn't draw this line on there. But say we had 0.7. So you were doing this, inverse sine of 0.7 on your calculator, okay? Now, this graph is in degrees. We usually graph in radians, right? But the period is still 360 or 2 pi. We okay? Do you see what happens when I graph the line 0.7? How many solutions are there? 2. The same thing happens when you do cosine, right? If I draw a line at 0.7, there's 2 solutions. The difference is when you do inverse sine, these 2 solutions are both less than 180. So it's possible they both fit in the triangle. Okay? Doesn't happen very often, but it's possible. When you type inverse sine on your calculator, okay, I'm reading from this part over here, guys. It says when you do second sine on your calculator, it will never give you 2 possible angle measures. We learned why, because inverse sine is, remember we did this yesterday? It's only going to give you an answer here and here in quadrant pi over 2 to negative pi over 2 or 90 to negative 90. Type second sine negative 0.5 on your calculator right now. Second sine negative 0.5. What'd you get? What? Negative 30 degrees. Can we have a triangle with a negative 30? No. Add 180 to that and you get what? Okay. Now I want you to type sine of 30, enter, sine of 150, enter. Same answer, yes? 0.5. The thing is, your calculator doesn't know if you want the 150 or the 30. So what you have to do, anytime you find an angle using second sine, okay, or inverse sine, you're going to need to examine whether its supplement works. What does that mean? So you're going to do the angle the calculator gives you from 180, right? To find that possible supplement. All right, one more thing. On this slide, it talks about in order to make sure that your triangle makes sense at the end, when you're all done, check to see that the longest side is opposite the largest angle and the shortest side is opposite the smallest angle. Remember that from geometry? Okay, so I'm going to do this one and you're just going to watch. It says there's some triangle ABC, A is 43 degrees, across from it is a side of 25, side B is 28, and I can then find angle A, angle B first, right? Everybody good? So I do the sine of 43 degrees is across from 25 in the same way the sine of B is across from 28. So I type 28 times the sine of 43 divided by 25, and that's going to give me the sine of B. Pull up my calculator. 28 sine of 43 close divided by 25, and I get a decimal. 0.764. I'm not going to round it, but I'll round it for my paper here. Now what? Yeah, I have to undo that or inverse sine, second sine of that answer. I use that so that I keep all the decimal places. I got 49.8 degrees. But this is where you have to remember, as soon as you did inverse sine, it could also be the supplement of that angle. So if I do 180 minus the number I just found, I get 130.2. Now, there's going to be a lot of times where you can throw that second answer out. But is it possible here that this is 49.8? Okay. The smaller angle is across from the shorter side and the bigger angle is across from the bigger side. Is it also possible that this is 130.2? We run into an issue sometimes where this adds up to too much already, right? But this plus 43 is 173.2. That would make this angle teeny tiny, but it's possible. We aren't over 180. And 130 is across from the bigger length, and 43 is across from a smaller length. This is possible that both of these work. So when are you going to know they can't both work? If the triangle is going to add up to over 180, with only two of the angles found so far, right? Or if this is, what if this angle given right here was already obtuse? Well, then it wouldn't work, right? Or what if the side you're across from is shorter than this? Then it can't be obtuse. Okay, so this is what I mean when I say we're just going to do our noggin rather than memorize a bunch of rules about whether it can happen. So let's solve this triangle. A, B, C. And side A is 12, side B is 8, and angle B is 61 degrees. What am I going to find first, guys? These are across from each other, these are across from each other, so I'm going to look for angle A first. So I'm going to do the sine of A is across from 12 in the same way the sine of 61 is across from 8. So when I type 12 times the sine of 61 divided by 8, closing your parenthesis around the 61. Anybody get 1.31? Huh. Anybody know what's going to happen? Can the sine be over 1? So when you do second sine of 1.31, your calculator says error. Okay, what does that mean? It's not possible for this to even make a triangle. What it's talking about, let me see if I could draw this. If you have a 61 degree angle here, and this side down here is 12, and there's a side of 8 dangling up here, it's not going to reach, okay? That's basically what's happening. All right, but when you get this second sign error, it means it's not possible. No triangle possible. It's going to be your favorite kind because you don't have to do anything else, right? All right, that's not the case on this question. All right, start again. ABC, angle A is 38. Oh my gosh, I'm going to start over. That's just so messy. I don't even want to. Oh, I'm still messy. B, C, 38 degrees, 8, 10. What are we going to find first this time? Okay, it says solve the triangle. Okay, we're going to find angle B is across from 10 in the same way that the sine of 38 degrees at A is across from 8. So I type 10 sine of 38 divided by 8, or I type it wrong. 0.7695, something like that. Anybody getting that number? Okay, then I do inverse sine of that. And anytime that you do inverse sine, and you're talking about a triangle, you got to remember what? The supplement. So do 180 minus that. And 129.7, did someone else get that? All right, this is where it gets tricky, guys. What students don't realize is how to find the rest of the triangle because they want shortcuts. You really have to do this twice. If angle B is 50.3 degrees, that will be a different angle C, right? Then if angle B is 129.7 degrees. What things could I check to decide if I should throw the 129.7 away? Okay, 129.7 plus 38 is 167.7, so that would leave a 12.3 degrees. Is that possible? Unfortunately, yes, it is, right? And is A is 38 degrees and it's across from a side of 8. So whatever we have, B is 10, side B is 10, across from it has to be an angle bigger than 38, but both of those work, right? Somebody find this for me. Okay. Now what do we have to do? We have to find side C separately for each attempted triangle. We can't eliminate either one. So over here, we're going to have the sine of 91.7 is across from C. In the same way, the sine of 38 is across from 8. I would use the 38 and the 8 because those were both given. And over here, the sine of 12.3 degrees is across from side C in the same way the sine of 38 is across from 8. Anybody get an answer for me? I'm going to round this to 13. Does that seem okay? I got 12.988. Don't forget to be closing your parentheses, otherwise things won't work out. Oh, I messed something up. Anybody get 2.8 for this one? But it would still work, right? Shortest side is across from shortest angle. I don't know if you remember this rule, but remember the sum of any two sides has to be greater than the third? Can a triangle have sides of 8, 2.8, and 10? Yes, it couldn't have 2, 8, and 10 because it has to be greater. Anyway. All right, moving on. Law of cosines. Law of cosines is longer and uglier, and you have to memorize it. Now, there's 3 versions on here. Do you have to memorize all of them? Well, they're not really that complicated once you know one of them, but no. On the quiz, okay, let me back up. Law of cosines works when you're given 3 sides or 2 sides and an angle in between. Those are the 2 situations it works for. You have to memorize one of these for the quiz and be able to state it on the quiz, okay? I always do B, I don't know why. But this is the one I have memorized that I usually write on my answer key. B squared equals A squared plus C squared minus 2AC cosine of B. All right, it's on the top of your sheet or middle of your sheet, wherever it is. Everybody ready to try this? So in this triangle, this side is B, this is side C, and this is side A, and this is angle B. It is a side angle side situation, right? 2 sides at an angle in between. So can anybody tell me what I'm going to write? Or what you would write? B squared equals 10 squared plus 8 squared minus okay. A pain in the neck, but you need to memorize it. then for this particular question, it's all just typing, right? Can you hit enter along the way a few times if you want? If you do, be very careful because all of this is multiplied together, yes? Okay, so if you wanted to hit enter after the 8 squared, you could, but don't hit it enter in the middle of all this. All right, so 10 squared plus 8 squared minus 2 times 10 times 8, all times the cosine of 100. Don't hit an enter in there and stop anywhere. Okay, is that the answer to the question? Is that side 191? We still need to square root. The best way to do that on your calculator is say I'm going to square root the previous answer, which is second negative. You guys, most of you can also scroll up and grab that answer, right? But to keep all the decimal places, I got 13.8. Someone get that for B? Okay. I don't want to spend a lot of time on this, but how would you solve for the other things in this triangle? Because it says solve the triangle, right? You could now say the sine of 100 degrees is across from what? In the same way that the sine of, doesn't matter, A is across from 10. Now, what's the good news here? Normally I have to do the supplement or the angle. Anybody know why I don't this time? Yep. I didn't square the cosine of 100. That's at 100 degrees right there? No, this is a degrees. Anybody else have a question? Okay, typing this in, 10 sine 100 divided by 13.8, inverse sine of that gives me 45.5 degrees. I should normally worry about the supplement, which would be 134.5. But why didn't I really care about that one? Don't I already have a 100-degree angle in the triangle? Can't have another obtuse, right? Okay, now do I need to do a lot of work to find C? To find angle C, I just need to subtract 180 minus 100 minus 45.5, which is 34.5. Did someone get that? Maybe? Okay. All right. Again, checking for reasonableness. When you are given, okay, a triangle can have at most one obtuse angle. The law of cosines will find you the obtuse angle right away. No subtracting from 180 business, okay? So the easiest way to check is to always do the largest angle first, okay? If the largest angle is obtuse, then you know the other two are acute. If the largest angle is acute, you still know the other two are acute, right? All right, what are they talking about? Well, in a triangle like this, you should find the largest angle first. What is the largest angle going to be here? C. So this is what I want to do. I want to do C squared equals so that I can find angle C. How does that go if I start with C? A squared plus B squared minus 2AB times the cosine of C. Okay, before we go any further, I need you to answer this question for me. Okay. Is this 0? Is that 8 minus 8x? Okay. I can't tell you how many people think that they should do this. Can we combine all that right there? This is all multiplied together, right? So can I just talk you through this quick? What I always do is I do c squared and I subtract a squared and b squared over to the other side. Does that make sense? If I subtract that on that, and then what's left here is what? A negative 2ab cosine of c. If this is my unknown, I'm going to now divide this by negative 2ab, and I'll have the cosine of angle C. I'm just trying to show you ahead of time, okay, the algebra. Let's go to the question. If I'm trying to find this angle, set that up for me. Oh, I thought that was an eraser. That wasn't working so well. Okay, guys, set up for me. C squared is 28, right? Squared equals what? What are A and B? So 20 squared plus 12 squared minus 2 times 12 times 20, or 20 times 12, times the cosine of C. Clearly that fits on my screen. All right. This is what I do. I do 28 squared minus 20 squared minus 12 squared equals negative 2 times 12 times 20 times the cosine of C. Then I find this answer. $240. Over here I have negative 2 times 12 times 20. So what am I going to do? 240 divided by negative 480, and then I'm going to do, to get rid of this, I'm going to do inverse cosine of that. Inverse cosine of 240 divided by negative 480, otherwise known as negative 1/2, gives me what? Angle C is 120 degrees. Does that work on your unit circle? Look at your unit circle real fast. Is the cosine of 120 negative 1/2? Okay, just checking. So this is 120 degrees up here. When you do law of cosines, you get one answer and it's the only answer, okay? If you lose that negative, are you going to get the right answer? No, so be real careful. All right, how would I finish solving this triangle? I'd have to do law of sines to find these one of them, and then do 180 minus to find the other one, right? Can I skip that part? All right. What law would I need to be able to find this distance BC? I'm kind of in a hurry. I'm not going to read the whole question. I have two sides and an angle in between. Cosines. Why not law of sines? I don't know anything across from anything, right? So what am I going to write? X squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 30. Type it all in, and remember to do what at the end? Square root. Okay, at first I got 16.8. Should I have known right away that it wasn't very reasonable? Because 30 degrees is not one of the biggest angles probably in the triangle, right? So 4.1 seems okay. It's across from a 30-degree angle. Oh, it's not degrees. Just kidding. It's 4.1 miles is the answer, right? No, we don't need to on this one. Just says from point B to C. All right, guys. I really want to keep going today. Can you go to the middle of 24A? Did I have you pull out both of them, right? In the middle of 24A, there are two more formulas you need to know. One is the formula, they're both formulas to find area of triangles, okay? Everybody have your pink sheet out. Look on the back of your pink sheet at the bottom. Do you see at the very bottom, there's a nice formula, area equals 1/2 AB sine C? Is that what it says? Okay, we'll do that one in a second. There's a one that's not so fun, and it's not on the pink sheet, it's my bad. So, I'm gonna put it on my brand new whiteboard up there, okay? Okay, so that it will stay there for the quiz. Let me do it right now. So here is this formula. And divide it by 2, okay? And find that magic number S. And then you're going to do this. S times S minus A times S minus B, S minus. How far was I smart enough to figure out that horrible thing? Okay. That's the area. All right? I'm leaving it up there. Try it. In a minute, I'm going to show you how to save it on your calculator. Okay. Oh, apparently now? Do we have to do more than one of these? Yeah. Let's do this one. Does this come out nice? Somebody add those three numbers up. 22, 36, and 20. Okay, so divided by 2. Let's do this. S equals 36 plus 20 plus 22 divided by 2, not by 3. Okay, so semi-perimeter is halfway around. So we get S is 39. So what we need to do is square root 39 times 39 minus 36, which is 3, times 39 minus 20, which is 19, times 39 minus 22, which is 17. All right. So 39 times 3 times 19 times 17 is a big number. And we need to square root that. I got 194.4. Anybody else? Okay, this is the area in square inches. Okay, can I show you how to do it on the calculator? Okay. On the calculator, what you're going to do is you're going to store that S number since we have to use it so many times. So I'm going to find the semi-perimeter. Tell me the sides again. 36. Oh, we're already messed up. 36 plus 20 plus 22. Enter divided by 2. Okay. So now I have 39 on my screen. You could just type 39 if you wanted. And then you're going to say, I'm going to store that right down here. Do you see this button that says store? Okay, I'm going to store it. And I'm going to put it into X because that's the easiest button to find. You could store it into S for semi-perimeter, but then you'd have to use that like alpha, whatever, to find S. I'm going to store it into X, enter. It's going to say 39. I need to tell you this. It does not matter that that's stored in there, okay? You can go and later use it and it won't matter. Don't freak out. I have to unstore that 39, okay? Don't worry about it. It's just going to stay stored in there until you either graph something or you store over the top of it, but it won't hurt anything. Yes. Okay. When you get you can just type 39 if you want. And then it's this button down here, Kendra, says STO right above on. Hit that, and then X, the X key under mode, and then enter. All right? Now, what I'm going to do is I'm going to go square root of X times, and now I'm going to do parenthesis X minus, what was it, 20 is one of them? Close parenthesis, parenthesis, X minus 36, close parenthesis, open parenthesis, X minus, what was the other one, guys? 22? And I could close the last parenthesis around the whole thing if you wanted. I got 194.4. Did you get it? So I didn't have to keep typing the 39. It's not that big a deal when it's 39, but what if the semi-perimeter is 27.83? That sounds like a pain in the neck to keep typing, right? So you can store it if you want. All right, try number, all right, how about we do girls do 6, boys do 7? I tried to do the subtraction in my head to see if anybody get 33.7, ladies? All right, gents, what did you get? 47.8? No? Okay, 16.5. Oh, that's supposed to be an 8.5 right there, isn't it? I was trying to do the subtraction in my head, but I typed this wrong. Let me see now. Okay, now I got 46.999. Is that what we got? Anybody not getting whichever one you tried to work? All right. Then there's the easy one that is on the pink sheet, right? If you know two sides and an angle in between, you can find the area using this formula, 1/2 AB sine C, or 1/2 AC sine B, or 1/2 BC sine A. Okay. Let's talk number 8 real fast. If I draw this triangle, I have RST, side S is 12, side T is 14, and angle R is 50 degrees. The most common mistake on this question, I'll tell you right now, is that people don't read the directions because they find other stuff. This wants the what? Area. So it's going to be 1/2 of 14 times 12 times the sine of 50 degrees. 0.5 times 15 times 12 times the sine of 50, making sure you're in degrees. I got roughly 16, well, I got 68.9 if I go to the nearest 10th. Anybody else get that? Okay, did I type that wrong? Oh, I have 15 instead of 14. Thanks, guys. 0.5 times 14 times 12 times the sine of 50. Okay. 64.3. Is that better? Okay. Wait, guys. Don't leave. Look at this slide. Take a picture of this slide because I'm not here tomorrow. This is what you need to work on tomorrow. A whole bunch of this is application, okay? It should actually be everything that's listed on that orange sheet that was by the door, okay? Yes, tomorrow is basically a work day. I may have her play a short video of the examples on applications, but if you want to ignore my video, be just working, that's fine too, okay? Oh, thanks. Yeah, I'm recording me blowing my nose.